In this assignment, we are going to analyzing the categorical data. So normally we will have two or more categorical variables. So we want to look at the relationship between those categorical variables. And in categorical data, it whether has two sides, like you win or lose, you pass or fail, you live or die. So in the categorical data, the mean really doesn't matter because the mean of those numeric values are based on how many subjects you have in each category. So when we analyze the categorical variables, we actually analyze the frequency, not the mean. So for my research question, I'm interested in looking at the relationship between sleep and homework to say if they affect how the student pass or fail their exam. So this is the data file I have. So I have people who did their homework or people who did not do their homework. And for the sleep variable, I have people who sleep less than 8 hours and people who sleep more than 8 hours. So those two categorical variables, I want to say the relationship between them to how they gonna pass or fail on their exam. So for the false variables, it's the frequency of each situations. So first, we want to create the contingency table that include the homework, sleep, and exam. Those variables all include in this table. And this is the result of the table, and it shows all the frequency. And we are going to use this table to do the log-linear analyze. So we created this saturated model, and we expected that it will fit the data perfectly. And the results of the likelihood ratio and and the p-value shows that the p-value is 1, so it shows that it meets our it's a perfect fit of the data. So in the next, we are going to see if all the main effects and also the two-way interaction will also fit our data or not. So right here, this function is to remove the three-way interaction. And this is the summary of the model that removed the three-way interaction. So as we can see, the p-value is less than 0.005, which means that this model is a poor fit to the data. So also we want to see, like, we want to compare the saturated model to the one without the three-way interaction, and we use this ANOVA function to compare those two models. So as we can see right here, the p-value is less than 0.05, so therefore it is significant value. So which means that when we remove the three-way interaction, has made the model a worse fate for the data. So in other words, the three-way interaction is a significant contributor to make this model to fit the data perfectly. So we want to make the conclusion that the three-way interaction is significant, and we don't want to remove the three-way interaction. So in the next, we are going to remove the two-way interaction. So right here, we remove the SNP and the interaction between the SNP and exam, the interaction between homework and exam, the interaction between SNP and homework. So we run those functions to remove the interaction. So right here, we have a ANOVA function to get a summary of those model compared to the saturated model. So right here we see the p-value is 0. I don't know why it shows 0, but I assume that it's a less than 0.001. So which means it is a significant value. So which means the interaction between the SNP and the exam is significant. In other words, when we remove the SNP and exam interaction from the model, so the fate of the model getting worse. And next, we are going to see the interaction between the homework and exam. So it's also the p-value is less than 0.001, which means it's significant value, and we can make the conclusion that the interaction between the homework and the exam is significant, which means the interaction is a significant factor in making this model a good fit. So we don't want to remove this interaction. So right here we have the interaction between the SNP and homework. As we can see, the p-value is about 0.05, which means it is not significant. So we can make a conclusion that the interaction between the interaction between the SNP and homework is not significant. We can remove this interaction. It doesn't affect our model. So in the next, we are going to do the following up analysis, which is a chi-square test. And right here, we create the contingency table that include the SNP and the exam. We want to see the interaction between them. So as we can see from the table, that when people sleep more than 8 hours, we have 126 people pass the exam and 26 people fail the exam. And when people sleep less than 8 hours, there's only 43 people pass the exam and 75 people failed the exam. So we can make the suggestion that people who sleep more than 8 hours are more likely to pass the exam. And also, we can see right here the p-value is significantly less than 0.05. So we can say that the interaction between the SNP and exam is significant. And also we can see the sample estimate odds ratio is 8 times higher. which we can use in our conclusion. And the second model, we can create the contingency table for the homework and exam. So also we can see right here, people who did their homework are more likely to pass the exam, and people who did not do their homework are more likely to fail their exam. And also the p-value is significantly less than 0.05. So, and right here the sample estimate odds ratio is 0.126, and so we want to make the conclusion that people who have more than 8 hours sleep are more likely to pass exam. However, students who did not do their homework are more likely to fail the exam. And we also want to use this odds ratios. We want to use the 1 divide these values, so we can get the it is 7.7 times lower if they had less, if the student did not do their homework. So we can make the conclusion that if people who have more than 8 hours sleep, they have 8 times higher pass rate than people who sleep less than 8 hours. And people who did not do their homework has 7.7 times lower pass ratio compared to the people who did their homework. And we can also run the function to get the graphs to see how the frequency shows. And this is the pass and this fail. And we can see when students sleep more than 8 hours, they are more likely to pass the exam. So when the student did not do their homework, they are not more likely to fail their exam. Yeah, this is analyzing categorical data.